now on, all the upcoming videos of this series will be available early for the members of the channel. That means that if you have the membership, you will get access to the videos before they will be released to the public. It's a great way to stay ahead and support the channel and dive into the content as soon as it's ready. Thank you so much for all the support, and as always, happy coding. Hello and welcome back to my YouTube channel, and this is going to be the next part of our CMP series. In this video, once again, we will be covering Kotlin Essentials, and like in the previous video, we covered null safety. In this video, I'll be talking about special classes in Kotlin. So basically, Kotlin offer a variety of different classes that we could use. Some type of classes might be available in other languages as well. But in this video, we will try to cover what kind of classes there are that we can use other than the traditional classes, and what are the benefits. So like what kind of like help we can get from them when basically using them in a real world projects. So let's just get started without wasting any time. So once again, I'll basically come over here to this Kotlin playground, and we'll basically start experimenting a couple of things. So when we talk about special classes, like we know the traditional class, we have already covered classes and constructor, but this video, I'll basically cover a couple more things. For example, Kotlin offers data class. That's one thing. Then we'll talk about a little bit about enum. Enums are available in like all the other languages as well, but to understand something else, we'll basically cover a little bit of enums and how they work in Kotlin. Then we will be talking about seal classes, a very powerful tool. Other than that, we will be talking about companion objects, what exactly the companion objects is and all that. Okay, so these are all these things. Okay, and now let me just explain each one by one, and maybe we'll try a little bit of experimentation and all that. So if we talk about a normal class in Kotlin, we know how we create something like this, and let's call that class as A. And this is pretty much similar to how we write a class in Java as well. But uh, when you'll be working with the like when you're working in real time scenarios, there are some certain kind of functionalities that are basically that we write when we basically even in Java we do that, and we use them. For example, if there is a class, let's call it class person, we need a couple of functionality. For example, as there should be function equals something like this. Then we will have a toString function inside this class as well. And like other than that, there are some other functionalities. So basically these are some functionalities that basically we need, or like we use or we write for so many things. And we'll basically, I'm not going to talk about like deep inside like why the equal function is used or why that toString is used. We'll basically use it in future, so you'll understand. But the thing is that there are certain functionalities, certain functionality that we use or like a class could have. One of that is hash code as well. There is one more function, copy. So basically, these are some functionalities. Normally in Java, what we do is that we implement all of them by our own, and this is basically that it involves a little bit of complications because there's so many things that you need to take care of. What Java or what Kotlin help is that if you want something that basically stores some sort of data, normally these functionalities are also used for certain type of classes. Like when we have some sort of classes that are containing some data and we want to compare them or we want to process them, so you basically use these kind of thing. The data class is kind of a special class that is basically provided in Kotlin, and what it helps is that it helps with keeping the data. Okay, like you can understand by the tag or by the keyword, it's data. But other than that, what it does is that, for example, I have a name like before, then we have wall age as string, and let's call one more thing as this. So basically We created a class that is basically the normal class that we have. I'm going to create one more class, class t person, and I'm going to use the same approach here as well. Okay, so basically I created these two classes, and one is the normal traditional class that we have. You can have that in Java, it's similar in Kotlin as well. And now what I'm going to do is that I'm going to create the object for both of them. Okay, and I'm going to name them, as the name is going to be FK, then we will be using age, let's call it 34, and then last one is going to be SE. Okay, and I'm going to do the same, like we'll be creating the same, but this is going to be t person, so that we can have two different uh, functionalities. Okay, okay, so what I'm going to do is that I'm going to say println. Okay, and we will be using print to string. Okay, so this is basically the data class that I used, and I basically called the two string for that, and then the other one is also, let's call that function for that as well. Okay, and now let me just run this and see how they both differs, at least to start with the two string. Okay, I should have placed an integer. Okay, now let's just try. Now you see, when I called two string on this specific class, the one that's the data class, you see we basically got a clean um detail of the class, but for the other one we just got the memory reference, right? And then it was just converted into a string. Now let's say you want to do that. What you have to do, you have to go to this section, create and override function to string. Okay, that is going to be string, and then over here maybe you can say person name is FK, comma age, uh, and occupation is equals to. Okay, so now I wrote this, and now when I run this, you will see that, come on, it's going to be name. Now let's just try once again. Missing return. Sorry about that. Okay, now let's just try this once again. Now you see, when now when I did it, you saw that I had to like write this whole functionality for this, and this is the same for something else as well. Let's say like create one more function. I call it as p2, or like p, let's call it p2 is equals to, it's going to be again person, and then you are gonna use the same data that we have for this, right? So basically that is exact same thing is there, we are not changing anything. And now what I'm gonna do is that I'm gonna comment these two lines. Instead, what I'm gonna do, I'm gonna say println p equals to p2. Now in this way, it's basically a total separate function, like a separate class, and this is a total separate two different objects. These are the two different objects, they're not pointing into one memory, but the data is same. Okay, that's just one thing that you need to compare. And now for the next one, I'm gonna do is that I'm gonna say p3, they are also same. Okay, and for this I'm gonna say println p1 equals to p3. So basically I'm using the equals function for both of the classes, and now I'll try to run and see how they both work. So let me just try running this. Now when I run this, you'll see for the first one I got true, although they were like two different instances, two different objects. But since the data was same, the data class internal equals function basically came into place, and it basically compared all these things, and I didn't had to do to like implement my own, that thing. Same goes for over here, that over here, since we didn't had like proper implementation of the equal functions,
it didn't compare anything. Like, so that's why it didn't basically return me a proper result. And if I want that from this, what I'll have to do is that I'm going to say equals. Now let's just try this once again, and now this time you see it returned me true, because now I had to implement all this. And they're like similar for hash code as well and all that. So the basically the purpose is that this data class helps you. If you have classes that contain some sort of data, you can always use a data class, and this data class will help you with all these boilerplate code as well. And also, like, it's like very clean. And there is one more thing, is that the data class, you can, for like when you're creating a data class, you need to make sure that you pass at least one parameter as a constructor. Like if I use something like this, and say wall item string is equals to something like this, right? When I run this, basically the compiler won't allow me. Come on. Okay, let's just try this now. So basic Okay, so now the compiler won't allow me, and it will say that it should have at least one primary parameters, and that's why you need to define at least one parameter in it, and then the rest can go inside the class as well. But like the ideal scenario is that you create something like this. I mean, using it. So basically that was data class. And there was one more thing with data class that I really and that is basically destructuring. So basically we know that we have a class, let's say wall p is equals to person, and it contains some sort of information like this. Okay, now later on, let's say I want to get some sort of information or some sort of values from this. So what I can do is that you can say wall uh name, age, and occupation is equals to p. So basically what happens over here is that this p class can contain like this information, and it will the information will be assigned to each of the variable accordingly, like without we having to creating variable and then assigning those values. So basically if you have like if you want to get some sort of certain values from the data class, you can just directly destructure it, and then it will assign to this, and now you can basically print ln each one of them separately. Like you can do something like this. So I'm gonna use age for this and occupation. So basically, these are the three variable that it creates, and then it assigns me all those value. And now if I run this, you will see that it gets all these value. Now let's say I want just two values from this. So if you want just two value, you can always get those two values, or like one values depending on your needs. So you can like define it. Let's say you want maybe the third value, not the first two values. So for that, I think you can do something as this and this. I believe if you do this, uh, it should work. Let me just see. Now let's just try running this, and now you will see that it took me the last value. So basically this underscore is kind of a variable without like using unused variable kind of thing. So you can do something like that to access a certain value if you like want to. So this is basically how um, data classes are destructured and how we can use it. So yeah, that's that. Now the next thing in this specific discussion that I'll cover is enum class. So basically what is a enum class? A enum class is kind of like, it comes from enumerator, and enumeration means that like if you have some certain type of values, and you know that like there won't be more or less, like it won't change on runtime. So for that kind of scenario, you use basically this. So for example, I'll give you an example of like if we're talking about days in a week. Now you know that in a week there will be only 7 days, and the 7 days are basically Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and there won't be any other addition to that. And let's say if that's not the case, you can also like think of it as like payment options. So for example, when you're making an app that basically gets the payment from the user, you can have some sort of enums for like type of payments that user can give. For example, user can pay in cash, they can have use credit card or debit card, or they can use PayPal or any other UPI that service that's available. So like in that case, you know that you have three different enums. The reason of getting enum, like writing a enum other than hard coding string, is that let's say for example, uh, Let's say I have a function, and that's basically process results. Okay, and that is going to be a string. And now what it does is that basically it process the results that you pass into it, and the result is something as when es. Now over here you say if it's pending, you do something. If it's in progress, you do something. And then if it's completed, here's something else that you do. Okay, and then let's say last one, you have this as well. Now the problem with this is that when I'm using, or like when I'm passing something into this and say let's say I call it process result, and I pass pending into this. Now when I pass the pending, this pending will not be processed by either of them, because you know that there's a difference in this string, and this basically makes it like problematic for the system to understand that there is no such thing as this. We need to pass it something like this, or there could be case when I pass this like a typo. So like these kind of issues can occur when you don't use when you use basically hard coded strings, and that basically can cause a lot of issues. So to help with that, what you can do is that you can say enum class progress type. Okay, and then over here what you can do is that you can define your enums as pending, in progress, and completed. Now rather than passing a string, what you'll do is that you'll pass that progress type, and then from there you know that what you need to do is that you need to define the progress type dot pending, in progress, and for completed you can pass completed. And now over here as well you can always pass the right. There is like no chance that you pass something different, because you are now accessing a direct variable or the direct value from this specific class, enum class that you have. So basically this is how it basically helps. And now basically when we talk about enums in Kotlin is not just limited to this. You can still do plenty of things with enums. So for example, you create a enum class planet. Okay. Now the planet can contain two different things. One could be the radius of the planet. The second could be the mass of the planet, right? Now what I did, like previously I just created one progress type and there wasn't any, but right now over here what I did is that basically I created a enum that contains at least two, that basically gets two value. And it doesn't matter if it's like a two value, depending on the need. It can be anything, it can be any size and all that. So basically it's just, to make you understand of how this whole structure, or like how the enum could work, right? So now I have done this. Now what I need to do is that I need to, let's say, create a couple of planets in this. For example, I need Earth. Now previously on for like the pending in progress, what I did basically we added just the name and then comma. Now what we need to do is that we need to add on a certain value into this, like we need to pass those values, the radius and the mass for that. So let's say we have some mass of 6,06371, like this. And the radius for this whole thing is 5.972. This is one value. The other one is basically going to be Mars. So now what I did is basically I created these values like this. And it's just not limited to this. You can also have some sort of functionality as well, that basically, so like say call it like surface gravity. So like what could be the basically gravity for the each planet, right? Say, so for that, let's say you have value g is equals to, let's say this is a value. And now what you need to do is that you need to define the gravity, that is basically is equals to g multiply by mass divided by radius into radius. So basically a radius square, right? This is basically a formula. I did just got it from internet. So we got this thing. Now this whole planet basically, it first it requires some values, some like kind of values that it contain, and then it also have some sort of functionalities that you can use. So later on, like when over here, let's say you want to create wall, earth is equals to planet. You say planet dot earth, okay, and now you can say println, and you can use earth dot surface gravity. For like this, you can just call that functionality over here and it will okay, something wrong. Okay, so basically these are some values that we missed, and we also need to define, since we need to we are accessing it outside, we need to define it as wall. What do we miss? Okay, we need to, this is also important, like the semicolon by the end of the types that we have, so that it can give the space for the other stuff. Now let's just rerun this. This time we'll hopefully be getting 9.8, which is like the gravity of earth. And basically you can do the similar, and like you can have multiple other functions inside that as well. It doesn't matter that it's just one, you can have as many functions as one, but like the enum, it should have like a very limited of these kind of functionalities just to help you out with certain type of thing. So this is enum, and this is how we can use enums. I basically explained two different kind of enums over here, and yeah, that's pretty much. Now the next thing after enum comes seal classes. A seal class is very similar to enums, but a enum and but like a difference between enum and a seal class could be like, so basically for enum it's like a certain instances, it basically covers certain instances. For example, what we did is in planet section is that we had earth, mars, jupiters, but all of these had similar values, like it had similar properties. We passed mass into it, we passed radius into it. But with seal class you can have, a seal class can have types, so each kind of, instance of it can have different kind of values, but at the end of the day they are still pointing to be as a similar, similar class, and that is basically how we use it. So basically the next thing would be to how, like when do we use seal classes, or what good that does they get, of implementing it. So basically the seal classes are basically used when you have some sort of states, that when you manage states in the class. Let's say you make a web request and you get response. The response can be of different kind, like it can be an error response, it can be a successful response, and even successful cases, there could be some cases where there is certain type of data that you can have, or in certain cases you have a certain type of things. So basically take it like this, like for example, if you have a seal class, let's call it response. Okay, so this is basically a simple class, and then inside that you can have multiple like other instances, multiple other type. For example, you can say data class success. So like in success case, you can have wall response as string, right? And then you have data class error, and you say wall message as string, and wall code as integer. And then other than that, you can say wall, it might be, object, or say data object loading, and it doesn't have anything. And at the end of the day, these all basically are basically a response. So basically, this is a seal class. In enum, what we did is that basically we did this part. We define all the default values on top of it, and then inside that we just created an instance of that, right? But over here, these are like different types. So the response is kind of a top class, and then it contains different kind of classes. It contains a success class. It contains a error class and it contains a loading class. So basically success is supposed to be having a string value, error should supposed to have a value as message and also an code that can be error code, and the data loading doesn't need anything. So basically for these kind of scenarios what we do is that we use seal classes, and that is basically the difference between having enum class or a normal class. Now the thing is that what benefit does it get? So basically the benefit of having this is that it makes your app a little bit type safe, or like a little bit, not a little bit, but like it makes your implementation type safe, because like the server can respond in any way. It can either be success, error, or like any other case. And if you have the seal class for that, you don't need to have if and else if condition inside your response. For example, in a traditional way, if you have a simple normal response, what it will does, that you'll have to add some check, if it's a success case and it has a 200 status code, okay, then you'll have to find a value of that, and then process that. So basically it basically makes it a little bit complex. With this, it becomes a little bit easier to manage and all that. So yeah, that's basically how seal classes works. And lastly is something that we will be covering, and that is going to be class, person, wall, name, string, wall, age, int. So let's say I have this class. Now, so if you're coming from Java, we have static instances that basically you can either create it inside a class or outside the class. A static instance is something that doesn't need so sort of initialization of all that. And you want to access something, you can directly just like type the class name, and then without the creating an instance of that, you can directly access that value. In Kotlin it doesn't happen. Like Kotlin, there is no static function, or like you cannot create a static method directly. So what you can do is that you can use companion objects. So basically a companion object is, just by name you can understand what it is. It is basically a friend of your class that can basically share some sort of information, a static information, or like the values that basically can be used. Now, the difference between a normal static in Java and a companion object is that this companion object is basically a singleton. So basically, only one instance of this is basically created throughout the system. And secondly, you can place some of your constant values that you can access later on. For example, let's say I want to add a tag, basically, that I want to create or like paste it over here, or maybe there are some other functionalities. The problem with static is that it basically gets created during the application initialization and all that. With companion object, it will not be created or used until unless, like, it will be a lazy initialization. So even if you don't use the tag, this companion object will not be created. And if you use that tag, the place that from where you are using, only then it will be creating that specific thing. And how I can access this whole thing is that you can just say print ln, and then you can just use person dot companion dot tag. If I'm not wrong, I think that's how it should be. And you can see now basically I can access it something like this way. You can see I didn't created the person class objects, I just directly accessed it. Okay. And this is basically how companion works. One thing about companion is that you can also implement interfaces with on these as well. It's not just the companion object that you can create. Let's say you have some sort of certain type of implementation that you want to have, you can always like create an interface, and let's call it type, and create a function get get type a string. So let's say I have something like this, and you can always have something like this, and then implement that functionality as an override function get type as string, and you can say return person like this. Now with this you can like, we used the companion, you can like use the get type as well and use it just like a. Okay, so I made a mistake while creating the override function, but now you can see that basically I returned a person over here, and this is how you can have your some sort of abstraction defined on your companion object. So you can do that if you want. And I think that's pretty much it for this video. In this video, what we did is that we covered special classes. We talked about data classes, how they can benefit, what kind of major functionality they comes up with. Then we talked a little bit about enums. Enum is always available in other languages as well, and you might have used them as well. But I just covered it a little bit more of how Kotlin handles it. Then we discussed seal classes and how basically seal class are different from enum and what difference does they make. Then we talked about companion objects, of what companion objects are, how we can access them, or like how we can create them, and how do we use them. uh, these all these four things that I've mentioned over here, we are gonna use them to the most in our implementation going forward. This was just an overview of how things are and how basically these all things work. So if you like the video, comment down below what you liked. If you didn't like the video, please share your suggestion, feedback, anything that I can use to improve the content that I create. And I'll see you in the next video. So till then, happy coding. Bye bye. Thank you so much for watching the video. If you found this tutorial helpful, don't forget to like, subscribe, and press the bell icon so you don't forget any update. If you got any question, you can join my Discord server. The link is in the description. Also, for quick updates and tips, you can follow me on Instagram. Until next time, keep learning, keep developing. Bye.